Chapter 17, Project Management. So projects are defined as a unique one-time operation design to accomplish a specific set of objective in a limited time frame. So an example of a project is the Olympic Games. So getting ready for the Olympic Games, running the Olympic Games, and then they're over and that's the end of the project. Producing a movie, so you start to finish, that's a project. Software development, product development, ERP implementation if you decide to implement ERP in your company. So projects go through a series of stages, a life cycle. So projects bring people together with a diversity of knowledge and skills, and most of the people remain associated with the project for less than its full life. The organizational structure affects how projects are managed. So the project life cycle is 5 steps: initiating, planning, executing, monitoring and controlling, and closing. So the project manager. So the project manager is the person in charge, and the project manager must effectively manage the work, the people, the communications, quality, time, and cost. So here's the project management triangle. So there's 3 things. There's cost, schedule, and objectives. So the more you want for objectives, the more it's going to cost and the longer it's going to take. Now if you try to squeeze this too much, if you try to get too much with not enough time, not enough schedule, you end up hurting quality. So there's behavioral issues with projects. So behavioral problems can be created or exacerbated by decentralized decision making, the stress of achieving a project milestone on time and within budget, and surprises. So the team must be able to function as a unit. So interpersonal and coping skills are very important. Conflict resolution and negotiation can be an important part of the project manager's job. So there's all kinds of problems to avoid. So most of the problems can be avoided or mitigated by effective team selection. Get the right people. Leadership, motivation, and then maintaining an environment of integrity, trust, professionalism, and being supportive of team efforts. So the project champion is the person who promotes and supports a project. So this isn't the project manager. This is someone who wants the project. They usually reside in the organization. They facilitate the work of the project by talking it up with other project managers who might be asked to share resources with the project team, as well as employees who might be asked to work on parts of the project. And the project champion can be critical to the success of the project. The work breakdown structure, or WBS, is a listing of everything that needs to be done. It's the logical framework for identifying the required activities. So it identifies the major elements of the project. It identifies the major supporting activities for each of the major elements. And it breaks down each major supporting activity into a list of activities that need to be accomplished. You can think of the work breakdown structure as really a hierarchical to-do list. So here's an example of a work breakdown structure. At the top is a project, and you break that into logical pieces. It might be software, hardware, It may be design. Whatever it makes sense. It may actually be pieces of the product, and then those three pieces are broken into more pieces and more pieces. And in a WBS, you call this level 1 of the WBS, level 2, level 3, level 4, and it goes down as deep as it needs to. So project management decisions are important. There's several steps that have to be taken. First is deciding which projects to implement, selecting the project manager, selecting the project team, planning and designing the project, managing and controlling project resources, and deciding when and if a project should be terminated. Okay, here's a couple of terms. PERT, which stands for Program Evaluation and Review Technique. You'll hear PERT used as a word. It's, PERT charts. And then CPM, it's called the Critical Path Method. So these are two techniques that are used to manage large-scale projects. So by using PERT or CPM, this is what you get. You get a graphical display of the project activities, an estimate of how long the project will take, an indication of which activities are the most critical to timely completion, and an indication of how long any activity can be delayed without delaying the project. Okay, so a network diagram is a diagram that shows the project activities in sequence and their relationship to each other. So there's two ways of doing this. You can do activity on arrow. In this, the work is done on the arrows. And then you can do, the second is activity on node. And in this, the activities are done on the nodes. So let's show an example. So on the left, these are the exact same thing shown two different ways. On the left is activity on arrow, and on the right is activity on node. So here you start, you do activity A, then you do activity B, and then you do activity C. So here you see that the activities are on the arrows, so that's activity on arrow. Over here it's the same thing. You do activity on A, then it goes to B. Do activity on B, then it goes to C. So I prefer this activity on node method over the activity on the arrow. It makes more sense to me. The most of the time I've seen the activity on the node, but it's good to know how to do both. So in this case, here you have A and B, both of them have to be completed before you can do C. So here, here's a different way of showing it. You do A, you do B, and both of those feed into C. Now this next one, I'm just going to do you can see that they're the same on both sides. I'm just going to go down the activity on node. In this case, A has to be completed before you can start B or C. And then this is one where A and B have to be completed before you can start C or D. So these two feed in, they both feed into C and they both feed into D. So those are some networking conventions. And when you're laying out a schedule, you're going to have to lay out all of these boxes. So time estimates. There's deterministic time estimates, and these are times where estimates are fairly certain. We know it always takes 1 week to do a certain job. And then there's probabilistic, and this is time estimates allow for variation. It's an average of a week. Sometimes you can get it done in a day. Sometimes it takes 2 weeks. So that's a probabilistic. So then there's a couple of conventions here: early start, early finish. So this is finding the early start, early finish through a network diagram. So early start is the earliest time an activity can start. It assumes all preceding activities start as early as possible. And then the earliest finished is the earliest time an activity can finish. So essentially, the earliest finish is the earliest start plus the time it takes to do that activity. So you think of early start, early finish. This is for people who want to get it done right away. And then late start, late finish, this is for the procrastinators. So this involves working backwards, and it's really the late start is the latest time the activity can start and not delay the project. How far can you procrastinate and not delay the project? So the latest start is really the latest finished minus the time it takes to finish the project, that task. So to do this, you start at the finish and you work backwards. So on earliest start, earliest finish, you start at the beginning of the project working forwards. Latest start, latest finish, you start at the end and work backwards. Slack and critical path. Slack can be computed two ways. You can either do it latest start minus earliest start, or latest finish minus earliest finished. Okay, and then the critical path is any activities with zero slack. So if you have no slack, you are on the critical path. So a knowledge of slack time provides managers with information about planning allocation of scarce resources. So control efforts are directed towards those activities that might be most susceptible to delaying the project. So activity slack times are based on the assumption that all the activities on the same path will start as early as possible and not exceed their expectation. If two activities are on the same path and have the same slack, this will be total slack available to both. Okay, so probabilistic time estimates. So you can do a beta distribution to describe the inherent variability of time estimates. So there's three estimates. There's the optimistic time. That's the time required under optimal conditions. The pessimistic time, the time required under the worst conditions, and then the most likely, and this is the most probable time required. So you end up with this beta distribution where here's the optimistic time, the pessimistic time, and somewhere in the middle is the most likely time. So a project is not complete until all project activities are complete. It's risky to consider only the critical path when assessing the probability of completing a project within a specified time. You really want to calculate the probability that each path on the project will be completed in a specified time, and you multiply those probabilities. And that's the probability that the project will be completed within the specific time. I've seen a lot of times when activities that are not on the critical path end up on the critical path because no one was worried about it. They used up all their slack time, and suddenly, Joe got sick, he was going to do it, and boom, you're on the critical path, delaying completion of the project. Time cost trade-offs. So activity time estimates are made for some given level of resources. And it may be possible to reduce the duration of the project by injecting additional resources. So why would you want to hurry up a project? So one of them is to avoid late penalties. The second is monetary incentives, or to free up resources for other projects. I want to get done with this so that I can start the next great project. So there's something called crashing, which is a shortening activity durations. And usually this is the use of additional funds for additional people, or more efficient equipment, or relaxing some of the work specifications. So essentially the project duration may be shortened by increasing direct expenses. And you might realize savings in indirect project costs. So here's some crashing activities. So here's the cost of crashing. So as you shorten it, the cost goes up. I mean, the cost of shortening goes up. And then there's your expected project cost. So as you shorten it, your overall project cost may go down. And so this optimum level here is where the sum of these two curves is minimized. Sometimes it doesn't make sense. It's like, why are we going to pay someone overtime so that we can get done sooner? Well, it's because, yeah, we're spending money on overtime here, but we're saving this other cost, and so there's this optimal amount of overtime, and so you figure out that crashing. Okay, so the PERT, there's some useful features of PERT. It forces the manager to organize and quantify available information and identify where additional information is needed. It provides a graphic display of the project and its major activities. It identifies activities that need to be closely watched and activities that have slack time. Okay, so there's sources of error. So the project network may be incomplete. There may be a box that you completely forgot about an activity that needs to be done, and it's not on the network. Precedence relationships may not be correctly expressed. When you're putting it together, you say, well, we have to do A, then we have to do B, and then we have to do C. Well, it turns out that you can actually do A and B at the same time. They just go into C. That's a source of error. Time estimates are inaccurate. We thought B was going to take 2 weeks. It actually took 3. And then there's this tendency to focus on critical path activities and ignore the other parts. And then the major risk events may not be on the critical path. So something could go catastrophically wrong that delays the project, or a major risk, and you're ignoring that because it's not on the critical path. So risks management is important. So risks are an inherent part of project management. Risks relate to the occurrence of events that have undesirable consequences, such as delays, increased costs, inability to meet the spec. So we're back to that triangle: time, schedule, performance. Good risk management involves identifying as many risks as possible, analyzing and assessing those risks, working to minimize the probability of those risks, and establishing contingency plans and budgets for dealing with any that do occur. So a summary: there's projects, there's the project management triangle, which is cost, schedule, objectives, and then you squeeze any of those, potentially quality, which is in the middle, could suffer. There's a work breakdown structure. There's PERT and CPM. There's network diagrams, time estimates, time cost trade-offs, and risk management.